right, here is another example on graphing rational functions, but this one is very unusual. We don't know the equation of the function. So I consider this to be a good example because this is something we cannot do using the graphing calculator. What we have here is information about the first derivative. They gave us a sign chart for f prime and also the sign chart for f double prime for this function. So we are given some additional bits of information. For example, that the limit of this function that we're trying to graph as x goes to plus or minus infinity is equal to 2. And also we know that x plus 2 and x minus 1 are factors of the denominator. So we know they appear in the denominator of this function. Even though we don't know the exact equation, we have some information about it. Okay, so let's use all the bit of information to graph this function. First of all, the fact that the factors of the bottom are plus 2 and minus 1, and I'm going to make assumption that there is no repeated factor on the top, then what would be the vertical asymptotes for this function? So you would set each of the factors down one at a time equal to 0, right? And if you said x equals negative 2 and x equals to 1, you are correct. Those will be the vertical asymptotes of this function because those are the points that make the function 0 at the denominator, which leads to the vertical asymptotes. So the other one is that x equals to 1. Okay, now we also know something about the horizontal asymptote from here. The limit of the function as x goes to plus or minus infinity is 2. That tells me that the horizontal asymptote is going to be the line y equals to 2. So there we have it. Okay, now let's look at the sign charts. First, I'm going to look at the sign chart for f prime. As a matter of fact, I find it helpful in this section to look at f prime and f double prime charts simultaneously. So for example, over the region from negative infinity to negative 2, the first derivative is positive. That means the graph should be rising. And second derivative is positive. That means the graph should be concave up. So where would you put the graph? So up to the point negative 2. Do you think it should be over here approaching the asymptotes or over here approaching the asymptotes? If you chose the top one, you were correct because the graph should be rising since f prime is positive, while at the same time it should be concave up. So this is going to be the correct graph for that region. It's approaching its horizontal asymptote as x goes to negative infinity, and it's also approaching its vertical asymptote while it's rising and concave up. Everything is satisfied. Let's look at the next region. From negative 2 to negative a half. Okay, the f prime is positive. That means the graph should be rising in that region. And if double prime is negative, that means the graph should be concave down in that region. So between negative 2 and 0 on the chart, we need a graph that is rising and concave down. So where would you put it? Rising and concave down. So it has to get close to its asymptote. It has to be rising and concave down. So I'm going to put something like this. Let me use another color there. Rising and concave down up to 0. Now we don't know where it's going to hit the x-axis or the y-axis, but I'm just doing a rough graph. All I'm putting is rising and concave down. At the same time, it is approaching the vertical asymptote as x goes towards negative 2, so that part is satisfied. And this next part, between negative 1/2 and 1, excuse me, that was negative 1/2 is given, so I need to make sure that my graph rises up to negative 1/2. I guess in my case that's almost there, but I'm going to be a little bit more specific. So up to negative 1/2, which will be a point like this, the graph should be rising and concave down. Now the only difference is, you could do the same graph like this. In other words, we don't know how high it goes on the y-coordinate, but all we know is in terms of the x-coordinate, up to x equals -1/2, the graph is rising and concave down. Okay. In the next region, from -1/2 to 1, the graph should be rising, but this time it should be concave up. So we're going to do a graph that is rising and concave up. So there it's basically changing concavity, turn to concave up for the remaining part. And then over the last region, from 1 to infinity, it should be decreasing while at the same time concave up. So concave up. Decreasing and concave up. So where would you put it? Would you put it here like this, decreasing and concave up? Or would you put it like this, decreasing and concave up? If you pick the top one, you are correct. And why? Because we want to make sure the graph approaches its asymptotes. If you put it here, the horizontal asymptote is no longer going to be the line that we drew earlier, the line y equals to 2. Whereas if we put it up there, indeed the graph is approaching its horizontal asymptote. So this is the graph of the rational function with the given specifications. Checking it once again, f prime, the graph should be rising pretty much everywhere except for the last region, right? That's what we have. If you go from left to right, the graph is rising on each of those quadrants except for the last one. And then if you check the concavity, it should be concave up everywhere except for the second quadrant. And with the second quadrant, I mean the second region from here to here. And indeed, that's what we have. The graph is concave up everywhere except in that from -2 to -1/2. All right, there is a similar exercise in your group activity. I think this would be a great time to go visit that example and see if you can put that one together with the given information.